Let's go, Grace!
It's time for Maths with Mr. Thomas.
Chapter 11, lesson number 6, the vector product. Now you will remember from last year, if you have a couple of vectors, A and B, you can work out the scalar product or the dot product, A dot B. And the way you work it out is you would have A1 times B1, add A2 times B2, add A3 times B3. However, if you did work that out, you would end up getting a scalar. Brilliant, it would be a scalar and not a vector. However, there is a way to multiply vector A and vector B together to give you a vector. There's not. There is. So, if you do that, it is known as the vector product, and it's sometimes called the cross product, and it's read as A cross B. So we've got the dot product, and that will give you a scalar, and we've got the vector product, or a cross product, which will give you a vector. The way you work it out is you would need a couple of vectors, A and B, and in order to multiply them together to give you a vector, you would use this. Bum, bum, bum. That is not an easy formula to remember, but there is an easy way to apply it. What you can do is, if you cover up the top row, you can then work out the determinant of the 2 by 2 matrix that is visible. So if you cover up that top row, you would work out the determinant of this 2 by 2 matrix here. And the way you'd work that out is you would have A2 times B3, take away your A3 times B2. And that would be what would go in front of I. Then you would have take away, and you would cover up your next row. So if you cover up that row, you're left with the A1 and the B1 and the A3 and the B3. So you would have A1 times B3, take away the A3 times B1. That would be the coefficient of J. And then if you cover up that last row, then you would have A1 B1 and A2 B2. So you could have A1 times B2, take away B1 times A2. So really you're covering up the top row, working out the determinant of the 2 by 2 matrix visible. You're repeating that with the middle row, then repeating that for the last row. And when you do that, what you would then do is you would collect each part together in a plus, minus, plus pattern. And these would be the coefficients of I, J, and K. It is worth noting as well, if you do work out the cross product, if you worked out A cross B, well, that will give you a vector. And that vector is always going to be perpendicular to the vectors A and B, as shown here. So an important property of the vector product is that the resulting vector, your A cross B, is always going to be perpendicular to both A and B. Let's try a few examples with this. Woo! So, example 1, let's say we're working out this vector here, the 1, the 2, and the 3, and we're multiplying that by 2, 1, and 4. So, we're wanting to work out the cross product, or the vector product. We know to do that, what we're going to do is we're going to cover up that top row, and we've got this 2 by 2 matrix remaining. So with that 2 by 2 matrix remaining, we work out the determinant of that. So we'd have the 2 times the 4 and the 3 times the 1, or the 1 times the 3. That will be the coefficient of I. We remember we're going to have a plus minus plus pattern, so we're then going to have a takeaway, and we do the same thing with the next row. So with the next row, we'd cover that up, and we're left with the 1, the 2, the 3, and the 4. So work out the determinant of that, we 2 by 2 matrix. So we'd have the 1 times the 4, and we're taking away the 2 times the 3, or the 3 times the 2. That will be the coefficient of J, and finally you would cover up your bottom row, and you would have again another 2 by 2 matrix visible. So the determinant of that one would have 1 times 1 and 2 times 2. So it's 1 times 1, take away 2 times 2, and that will be the coefficient of K. If you work that out, well, that's going to be 8 take away 3, so that will give you 5i, or I times 5. We're going to be taking away j times, that works out to be negative 2, and then we're going to be adding on k times, and then that's negative 3. Rewriting that, that means we will have 5i plus 2j take away 3k, and that will be our answer. Woohoo! Let's try another one, example 2. If A equals 3i take away j plus 2k and B equals 2j plus k, find the vector product A cross B. So to work out A cross B, let's first of all write our vectors in component form. So taking the coefficients, we'd have 3, -1 and 2, and we're multiplying that by, well, we've got 0 i's, just like Granny. We've then got 2 and we've got 1. So we would have the 3, the -1, the 2, and we're multiplying that by 0 to 1. To work that out, so our A cross B, cover up that top row, and we would then have the coefficient of I would be, take the determinant of that 2 by 2 matrix that's divisible, so -1 times 1, take away 2 times 2. Remember the plus minus plus patterns we're then going to be taking away, and it's going to be j times, cover up the middle row, and we've got the 3, the 0, the 2 and the 1, work out the determinant of that 2 by 2 matrix, so 3 times 1, take away 2 times 0, or 0 times 2, and then we're going to be adding on, cover up the bottom row, and work out the determinant of this 2 by 2 matrix. So 3 times 2, take away 0 times -1. If you simplify that, that will be I times, that works out to be a -5 there, if you work that out. That'll be take away j times, if you work this out, it just works out as 3, and then you'd have plus a k times, and that will give us 6. That means then, if you rewrite that, the resulting vector, A cross B, will be -5i, take away 3j, plus 6k. And that's your answer. You got that? High five. Well done. Next one. Example 3, if A equals 3i plus 2j, take away k, B equals I, take away j, take away 2k, and C equals 4i, take away 3j, plus 4k, find A times, and then in brackets you've got the B times C. So the first thing we're wanting is this B times C, or B cross C. To work out B cross C, once again write vector B and vector C just in component form. So for B, if you take the coefficients of I, j and k, you would have 1, -1 and 2. And we're multiplying that by C, take the coefficients, you've got 4, -3 and 4. You're wanting to work out B cross C, so to get that, first of all, once again, you cover up that top row, and you've got this 2 by 2 matrix remaining. So you would have I times, and you'd have -1 times 4, take away -3 times -2. Plus minus plus pattern, so you would have take away j, and then you would have, cover up the second row, you'd have the 1, the 4, the -2 and the 4. Work out the determinant of that, so 1 times 4, take away 4 times -2, and then you plus minus plus pattern, so plus k times, cover up the bottom row, and you've got this 2 by 2 matrix. So 1 times -3, take away the 4 times -1. If you work that out, well, it's going to be I times the -10. It's going to be take away j times, this works out to be 12, and plus k times, and this works out to be 1. Meaning then, you will have -10i, take away 12j, plus 1k, or just plus k. So we've worked out B cross C. We know we have A cross the whole B cross C. We've just worked that out, so now we're wanting to multiply A by a result. So it's going to be A times the B times C, or A cross B cross C. So vector A in component form, take the coefficients, we've got 3, 2, -1, and we're multiplying that by a result from just this first part here, which will be the -10, -12, and 1 if we write in component form. To work that out, we start by covering up the top row. So cover up the 3 and the -10. We can see we've got this 2 by 2 matrix remaining. It will be visible. So the coefficient of I will be the determinant of that 2 by 2 matrix. So it's going to be I times 2 times 1, take away -12 times -1, plus minus plus pattern. So we'd have take away j times, cover up the middle row, and we've got the 3, the -10, the -1, and the 1. So 3 times 1, take away, and we've got -10 times -1. Plus minus plus patterns, it'll be plus k times, cover up the bottom row, and you've got the 3, the -10, the 2, and the -12. Work out the determinant of that, so 3 times -12, take away the -10 times 2. If you simplify each of them, well, you will be multiplying I by, this works out to be negative 10. You will multiply j by, this here works out to be negative 7, so you'd have negative j times negative 7, and then you'd have plus k times, and if you work that out, you get negative 16. Rewrite that, and you end up with an answer then of negative 10i plus 7j take away 16k, and that there will be your answer. Woo! Example 4, a plane is parallel to each of the vectors A, which can be written as 4i take away k, and B, which equals 6i take away 2j plus 3k, and the plane contains the point 3, 4, negative 7. Find the equation of the plane. So, how do we go about doing this? Well, we know here the plane is parallel to each of these vectors, and we're wanting to find the equation of the plane. But to work out the equation of the plane, what we need is a normal vector. Perfect, we need a normal vector. And for a normal vector, that will be one at right angles to the plane. But if you work out A cross B, well, A cross B is always going to be at right angles to both A and B. So if you've got the plane that's parallel to both of these vectors, well, to get the vector that's at right angles, you can work out A cross B, because that will be at right angles to A and B. So the vector n, the normal vector, A cross B, will be a vector normal to the plane. So let's work out this normal vector. This normal vector will be A cross B. So to work that out, we're going to write both A and B in component form. So for A, you would have 4, 0, because there's 0j, and negative 1, negative 1k. And we're multiplying that by vector B, which will be 6, negative 2, 3. To work this out, we do the same thing. The formula is just here. To work out A cross B, well, remember, you cover up that top row, and the coefficient of I will be, work out the determinant of this 2 by 2 matrix. So 0 times 3, take away negative 2 times negative 1. Remember the plus minus plus pattern, so it'll be take away j times, and if you cover up that middle row, then you're left with the 4, the 6, the negative 1, and the 3. So work out the determinant of that. So that will be 4 times 3, take away 6 times negative 1. Plus minus plus pattern, so we'll then have plus k times, and if you cover up that bottom row, we will have the determinant of the 4, 6, 0, and negative 2. So that will be 4 times negative 2, take away, and 6 times 0. Simplify each of these, so it'll be I multiplied by, this works out to be negative 2. You'd have take away j times, this works out to be 18, and you'd have plus k times, and work out what's in the brackets there, you get negative 8. Rewrite that then, and you will have negative 2i, take away 18j, take away 8k. So that there will be the vector n, the normal vector. Because that is the vector normal to the plane, if you take the components, the negative 2, the negative 18, and the negative 8, what it means is the equation of the plane, which we looked at in the last lesson, will be of the form, and if you take the negative 2, the negative 18, the negative 8, and put them in front of x, y, and z, so you'd have negative 2x, take away 18y, take away 8z, and that will equal k. Yes, just for some constant k. What we want to do though is we don't just want to leave it as that, we want to find the value of k. How do we go about getting the value of k? James, what can we do? Sub in a point! Yes, we can sub in a point, and the point here, the 3, the 4, the negative 7 lies on the plane. Well done, James. So you can sub that in. So the point 3, 4, negative 7 lies on the plane, so we can substitute in these values for x, y, and z. Sub in the 3 for x, the 4 for y, and the negative 7 for z. Sub that into the equation of the plane. Going over the page to do that then, that's just what we had in the last page. So we will now have, that's the equation of the plane, and subbing in these values for x, y, and z. So replace x with 3, replace y with 4, and replace z with negative 7. If you end up working that out, well, that will be negative 6, that will be take away 72, and that will be plus 56 equals k. And if you work that out, you get negative 22. Perfect. so k will equal negative 22. This means then that the equation of the plane is, well, the equation of the plane is just here when it's equal to k, but because we just worked out k, we can replace that with our negative 22. Perfect. So that there will be the equation of the plane. Once again, you could multiply through by negative 1, so you're starting with a positive term, so you could always rewrite that as 2x plus 18y plus 8z, and that will equal positive 22. So instead of every term being negative, multiply both sides by negative 1. What you could also do, yes, you could half every single term. So if you half everything, you would get 1x plus 9y plus 4z equals 11. Or you could have done that there, and you could have added the negative x, take away 9y, take away 4z equals negative 11. So you can write it multiple ways, all of which are accepted. Woohoo! Last example, example 5. Find the equation of the plane which contains the points A, B, and C. So A is negative 2, 1, 2, B is 0, 2, 5, and C is 2, negative 1, 3. So how do we do this? Well, if you want the equation of a plane, you need to work out the normal vector. So to work out a normal vector, well, what we can do is we could work out a couple of vectors on the plane. So let's start off saying then that the vectors AB, you can use other vectors, which I'll explain at the end. So let's work out both AB and AC, because AB and BC would be two vectors that would lie on that plane. So working out AB, to work out AB, it's going to be B minus A. So we're going to write them in component form. So we'd have the 0, the 2, and the 5, and we're taking away that negative 2, 1, 2. So take them away, and it means AB will have the components 2, 1, and 3. So that is the vector AB. Vector AC, so vector AC is going to be C take away A. So if you write that in component form, you'd have the 2, the negative 1, and the 3, and we're taking away again the negative 2, 1, 2. Subtract them, and you end up getting 4, negative 2, and 1. So we've now got two vectors that would lie in that plane. How would we work out the normal vector? What could we do? Perfect. To work out the normal vector, the vector that's perpendicular, what we can do is we can multiply both AB and AC together. So we can work out the vector or the cross product. So work out AB cross AC, because that will be a vector that's normal to the plane. To work that out then, so your normal vector, the AB cross AC, will equal, well, we've got them both there in component form. So we've got the 2, 1, 3, and we're multiplying that by the 4, the negative 2, and the 1. To work that out, once again, you're doing the exact same things we did with the other 4 examples. Cover up that top row, the coefficient of I. You're going to have I times. You're left with this visible 2 by 2 matrix to work out the determinant of that. So 1 times 1, take away the negative 2 times 3. Plus minus plus pattern, so we'll have take away j times, cover up that middle row, and we would have 2, 4, 3, and 1, work out the determinant of that, so 2 times 1, take away 4 times 3. And then plus minus plus pattern, so we'll have plus k times, cover up the bottom row, and work out the determinant of the 2, 4, 1, negative 2. So we'd have 2 times negative 2, take away 4 times 1. If you simplify just what's in the brackets here, you will end up with I times 7, you will end up with negative j times negative 10, and you'll have plus k times negative 8. Rewrite that, and you will end up with 7i plus 10j, take away 8k. Just remember that there is going to be your vector that is normal to the plane. That's your normal vector. So if you take these numbers, the 7, the 10, and the negative 8, you could sub them into the equation of the plane. AX plus BY plus CZ equals K. So replace A with 7, B with 10, and C with negative 8. And that means then the equation of the plane will be this, with 7x plus 10y take away 8z equals K, where K is just a constant. Once again, don't leave the equation of the plane as that. You actually want to find out this value of k. How can we find the value of k? What can we do, Lily? Perfect. You can sub in a point. Which point do you want to sub in?
Oh.
Let's do that then. So the point A lies in that plane. Perfect. So we can sub that in then. to the equation of the plane. So we're going to replace our x with -2. We're replacing our y with 1 and replacing our z with 2. So if you do that, that's the equation of the plane. Replace the x, the y, and the z just with what I said, the -1, -2, the 1, and the 2. And it means then the value of k will work out to be -20. Perfect. So you get k to be -20. That means then the equation of the plane, all you're doing is just rewriting what you had up here. Hello! But you know what k is, so you can say k equals -20. So you'd have 7x plus 10y, take away 8z, and that would equal that -20. Woo! That would be your answer. As I said right at the start, you did not have to use those two vectors that I was using. You didn't just have to use AB and AC. You could have used other vectors as well. So you could also have used AB and BC because they would both be parallel to that plane. You could have also have used AC and BC. Again, they would have been parallel to that plane. And again, up here, when you're subbing in that point to find the value of k, you could have subbed in any of the points. Both A, B, and C are lying on that plane, so you could have subbed any of them in. Try some of these questions in the Unit 3 booklet, page 42 and 43. Check your answers as you go. Good luck working out the vector product, or the cross product. Woo! Yeah. Well done. Bye.